Calorimetry example number 3. This time we've got 100 centimeters cubed of a copper sulfate solution at 0.2 moles per decimeter cubed concentration, and we are going to add 2 grams of magnesium powder. The temperature of the solution rose by 25.1 degrees C or Kelvin. Work out which reagent was in excess and then calculate the enthalpy change for the reaction. Okay. Assume that the density of the solution was 1 gram per centimeter cubed, so that means that straight away we can convert this into 100 grams. The specific heat capacity is again 4.18. Ignore the heat capacity of the metals. So again, straight away, Q is equal to MC delta T. Let's list them. Trying to work out that one. Now the mass, although we're adding 2 grams of magnesium, we are determining the change in temperature of 100 grams of the original solution. So the mass in this case is going to be 100 grams. The C is 4.18 and the delta T, we're told, is positive 25.1. So sub your values in. Q is equal to 100 times by 4.18 times by 25.1, and we get a Q value of 10,490 joules, which is the same as 10.49 kilojoules. So next, line down here. Next, we're going to have to work out the number of moles of the copper sulfate solution, and we do that using MV over 1000. So the molarity is 0.2 times by 100 over 1000, and that equals 0.02 moles. Now the number of moles of the magnesium is going to be M over MR, and that's going to be 2 divided by 24, and that's 0.0833 reoccurring moles. And what that tells us is that this is a much bigger amount than this one. So this here is our excess reagent, and it asks us to work that out in the first place. So back to this, work out the delta H. Now to work out the delta H, we always use the limiting reagent, okay, in this case, which is 0.02. So it's going to be equal to negative Q over delta H. So it's negative Q 10.49 divided by 0.02, and that equals minus 525 kilojoules per mole.